Okay, thanks for the introduction. Okay, my name is Josselin Feist. I'm a security researcher at 12 Bits. And today we are going to talk about upgradability for smart contract. We are going to see what are the solutions to have upgradability mechanism inside a smart contract, what are the benefits and the issue for each solution. And we are going to discuss what are the possible alternatives to this upgradable system. So, upgradability. As you are probably aware of, once you deploy a smart contract on Ethereum, you cannot update its code. The code is meant to stay forever, and a smart contract is designed to be immutable. So if you think about this design, it's kind of great for the user because with this immutable smart contract, you can build a trustless system where the user does not need to trust the owner. He can just read the rules of the contract, and if he agrees on the rule, he can interact with the contract. Now, as a developer, it's not necessarily totally great to have this non-upgradable system, because if after the deployment you want to add a new feature, or if you find a bug after the deployment and you want to fix it, you can't. So during the past months, we saw this new trend in smart contract design, which is the add of upgradability capacity to smart contract. We saw two main strategies to achieve this goal. The first one is called data separation, and the second one is called Delegate called Proxy. We're going to see in detail both of this strategy in a few minutes. So all the content of this talk and more detail about this subject are inside this blog post if you are interested in this topic. So the first pattern is called data separation. If you have a contract and a system, what you can do is that you can split into the logic, the functionality of your contract, and the data, the variable. And you can create a system with two contracts. One contract will hold the logic, the functionality, and one contract will hold all your data. So the data contract can be seen as a kind of database where you can only read and write variable. Or the logic contract is just all the functionality of your system. So in this pattern, the user will interact with the logic contract, and the logic contract will read and write to the data contract. So now, if you want to upgrade your system, what you need to do is simply to change the logic contract. You can keep the same data contract, and you just change the entry point of the system to get the new functionality. So as you can see here is a small example of how you can do it. So something which is kind of important is for the data contract, for your database of variable, to have this ownership capacity where only the logic contract can write to the data contract, because you don't want anyone which is not authorized to change the variable of the system. Inside the logic contract, you need to have a pointer to your data contract so that you can call and read the variable or write the variable. So there are many alternatives and different ways to implement this solution. One issue that we saw in many clients to implement this solution is that every time you will deploy a new logic contract, you will change the entry point of your system. So it might be a bit annoying from a new user perspective. So there is this alternative which simply add a new contract, which is a proxy, which will be the constant entry point to your system. So now you have three contracts, the proxy, the logic contract, and the data contract. The user will interact with the proxy contract, and if you need to change the functionality, you just need to change the contract in the middle. So if you want to implement this kind of solution, you need to have a really clear separation between the data and the logic of your contract, because you will need to split into two contracts. As I mentioned, there are many ways to implement this solution. What we always recommend to our client is to always try for the simplest solutions that fit your need. You don't need to build the more generic system, the more complex system. You need to really determine what you need to, when you need to have, and strive for the simple implementation that fits this need. Something that developer tends to forget is, in addition to this system, you need to have a really clear documentation and procedure on how to upgrade your system. Because you will have multiple pointers, you may have a posable system. So when you will need to upgrade your system, you need to have this clear procedure on how to do it. Also, because you have now the capacity to completely change your code, you need to be really careful in the way you will store the keys that allows to change the system. So you also, in an operational point of view, need to be really careful how you store this key, what are the access management to this key. And finally, it's also really important to have a clear communication plan with your user if you want to upgrade your system, why you want to upgrade, what you will change. So this was the first pattern to have this upgradability capacity to your contract. The second pattern is called delegate call proxy. It's a bit more complex to understand. So I will just recall some basic knowledge about the EVM virtual machine. So as you may be aware of, the EVM virtual machine is what we call an Harvard architecture, in the sense that you have a separation between the code section and the data section. From a contract, what you can do is that you can call another contract, right? But you can't directly write to the data section of another contract. If you want to change the state of another contract, you need to go through the function of this contract. In EVM, there is this specific opcode, which is called delegate call. What it does is that it will allow a contract to execute the code from another contract within the context of the caller. So if a contract A delegate call to a contract B, the code of the contract B will be executed within the context of the contract A, so on the variable of the contract A. This specific opcode is needed and is useful if you want to design a library. Typically here, you have a library in Solidity. You have two contracts, one contract C and one library lib. So you will deploy two contracts, and you need a way for the library to change the state variable of the contract C. If you use and you compile this with Solidity, Solidity will use this delegate call opcode. As you may suspect, it's really, really important for the callee to be aware and to follow the memory layout of the caller, because you will allow another code to change your own variable. If you use library with Solidity, it's okay, because all the translation, all the address will be computed by the compiler, so it works well. It's a bit more complex and tricky if you want to use delegate call at the user level, because you need to be really careful about this memory layout. In a few slides, we will have some example of how it works. But let's go back to upgradability. So how you can use this delegate call instruction to add upgradability capacity to your contract. So this pattern using delegate call works with two contracts. This time, the first contract, the one where the user will interact with, is called the proxy contract, and the proxy contract will have the variable. Every time the user will call the proxy contract, the function will be executed on the logic contract using this delegate call mechanism. So you can see, you can think about this pattern as a kind of dynamic library system, where every time you want to execute something from the proxy contract, the code from another contract will be executed. So now, if you want to change the functionality of your system, you simply need to change the pointer to another logic contract. But the issue is that you need to be really careful that this new version of the logic contract will follow the exact same memory layout than the previous version, right? Now you can ask yourself, how Solidity store the state variable in memory? How many of you are really familiar and really confident and they know like 100% sure how it works? So the short answer is Solidity will take the variable by order of declaration. the first variable will take the first slot, the second variable will take the second slot, and so on. The long answer is it's a bit more complex. So if you take this example of delegate call implementation, you have one contract, which is called Proxy, which just transfer all the function using delegate call to another contract, which now is my contract version 1. In Proxy, you have two state variables. In my contract, you have two state variables. So now, if you ask Proxy to execute the function set, it will execute the function set from the contract my contract version 1, and my contract version 1 will change the first state variable, which is A. It's A in both contracts, so everything is fine. Now, if you update your contract, you change your logic contract, so my contract implementation, and the only modification that you made is that you change the order of declaration of the variable. If you do so, when the proxy will want to execute the function set, it will execute the function set on my contract version 2. And because the order of declaration is not the same as before, it will change the second variable in memory, which within the context of proxy is a pointer. So now, by executing the function set on the second implementation, you change the pointer of proxy, and you just completely break your contract. So you have no way to recover from this. Just because during the upgrade, you change the order of declaration of your variable. So this is just one example of what can go wrong. There are many other issues that can arise. For example, if you remove one variable and you have multiple inheritance, you will change the order of declaration because in the second contract, the variable that was, for example, the third one will become the second one in the array of contract. Something a bit more tricky, if you change the type of your variable. So due to optimization, if Solidity finds that two consecutive variables can fit in one slot of memory, it may pack them. So if you change 2uint to 2uint8, Solidity will pack them together and will use only one slot in memory instead of two. And by doing so, again, you change your memory layout. Another example is the order of inheritance. If you inherit from A and B, and in your new version, you inherit from B and A, you will change also the order of declaration of your function, of your variable. So again, you will break the memory layout. So if you want to use this delegate call proxy pattern, you need to be really, really careful when you do a change inside your code. You should never remove a variable. You should never change the type of a variable. You should be really careful with inheritance, in particular if you have multiple inheritance. Once you deploy your contract with a specific version of the compiler, you should keep the binary version of this compiler and always use the same for all the future versions. Because as we already discussed, there are not right now a lot of optimization done by the compiler. In 6 months, 1 year, will change. Compiler could also change the way it stores variable in memory. So once you use this contract, you should always stick with the same compiler version. Something I didn't speak about is that you cannot use constructor if you use this pattern. You need to have initialization function. So you cannot use the constructor inheritance workflow from Solidity. You need to use initialization function, and you need to follow the correct initialization function inside your inheritance. If you don't do it right, also you may be subject to waste condition on this initialization function. Finally, as of today, there is no tool that can take 2 contracts, 2 compiled version of the contract, and check if they follow the same memory layout. Which means that if you want to do an upgrade, you need to go at the EVM level and manually check that both contracts follow exactly the same memory layout if you want to be sure that you will not break anything. Finally, as the same as for the data separation pattern, you need to be really careful about your documentation, about your procedure, how you upgrade, how you store your keys, and how you communicate with your user. So as we saw, it's kind of cool to have this upgradable system in smart contract because it allows you to patch your code. But in the other hand, it also brings a lot of potential issue with your code. As a developer, it will increase the complexity of your code. It will increase the size of your code. In an operational point of view, it will force you to be really more careful about your keys. And finally, I think that as a developer, if I know that I cannot easily change my code, I will be really careful about what I am doing. If I know that I can patch every week my code, I may be a bit less careful. So it's not necessarily a bad thing to be forced to have this requirement. For the user of your system, there are also some issue because you will have one additional contract for both patterns. You will increase the gas cost. So if you have two systems that does the exact same functionality, one has this upgradability mechanism and the other doesn't have, the second one will be cheaper to use for the user, which is a competitive advantage. And finally, having this way of completely changing the rule of your contract kind of break this trustless system that many smart contracts try to have. So if you want to implement this upgradability into your system, be really careful about the feature and the characteristic you implement. As I mentioned, we will always recommend to strive for the simplest solutions that you can have that will fit your need. We definitely recommend to use the delegate to use the data separation pattern over the delegate called Proxy because it's simplest to implement. And finally, if you want to have an upgradable contract, don't add this feature at the end of your development process. It's not like 1 week before the deployment, you should ask yourself, oh, should I add this complexity to my contract? No, you should consider it in the middle of your development, if not at the beginning. So as we saw, upgradability are nice, but there are a lot of drawbacks and there are a lot of issues with the system. We can ask ourselves, is there any other alternatives that provide almost all the same benefit without all this complexity? You already have the answer, which is the contract migration. So what is a contract migration? It's simply the fact to take the variable from one contract, deploy a new version, and copy all these variables to the new version. So why people use contract migration? First, to upgrade a contract which is not upgradable, you can just deploy this new version and copy all the variables. But even if you have an upgradable contract, you may at some point need a migration. Because if your contract gets compromised in a way you cannot recover, if someone stole your key, you won't have any way to recover them. Or if you put the contract in a configuration for which you cannot recover. So how does it work? Basically, there are two steps. The first step is to collect the data, and the second step is to write this data to the new instance. We have a blog post that lists some recommendation about how to perform this migration. We made, you may ask, like, how much does it cost to copy and write all this data to a new instance? We made some estimation back in October, and as you can see, it's not that expensive to copy all the variables from one contract to another. And this price was done back in October. It's obviously a bit cheaper right now. So if you think about it, you will realize that the migration will cover most of the benefit of the upgradable system, while not having all the issue of the upgradability. It will be simplest. You won't have any additional code to add to your contract. You won't need additional storage of key. You won't need additional cost from the user, and you won't need any additional complexity to your system. And even if you have an upgradable system, at some point you may need a migration. So anyway, you need to have this procedure and you need to know how to do it. So you may ask, when is there any case where an upgradable system is still useful? There are some. As I said, one migration is cheap. If you want to upgrade every week your contract, may become costly. So if you are a system where the code will change frequently, it may be too expensive to do always a migration. One issue with the migration is also every time you deploy a new contract, you will change the address and the entry point of the system, which may be more complex in a case where your contract interacts with other contracts. So the main takeaway of this presentation is that prepare a migration procedure. Even if you have an upgradable system, it's something you should consider, something you should know how to do it. Once you have this procedure, once you are clear on how you can migrate your contract, you can ask yourself, do you still need an upgradability? If so, be sure to hire a security expert to review your code and your procedure at the end. Because upgradability are complex feature and it's very easy to make mistakes. And here are the two blog posts I already mentioned in the presentation. Any question?
Yeah, I was curious what your thoughts were on the unstructured storage design pattern that Zeppelin OS and others use to kind of obviate the storage layout problem.
So yeah, there are many ways to store the variable in your contract. And if you follow some guidelines, I will tell you to follow the unstructured storage or any other one. All of them have like benefit and issue. So if you follow a storage where at least you have one contract and you inherit always for this contract for the data, you will make less mistakes. So it's not except of issue, but there are some alternatives that are a bit better, but not like magically solving the problem.
Going back to where you talked about the contracts, if you switch the order of the variables in the contract A and contract B, you said that it would point to A in the second position, even though it had switched from 0 to 1. So it wouldn't write to the address pointer, it would write to using the memory location from the inherited contract, the library contract?
So in the example with the two contract, so just back. So you have two variables in both. This example, right?
Can you go forward?
What?
Sorry, one back. Yeah.
Okay. So here, at the beginning, you use the proxy contract with my contract version 1. Both follow the same memory layout. And in fact, you are sure that because they follow the same memory layout, when you will use delegate call on version 1, you will write to the same variable. The issue is that once you change order of declaration, once you will execute set on this new version, my contract version 2 will execute the code that will change the second variable in memory, which within the context of proxy is a pointer. That makes sense?
Hey, this is kind of related to the delegate call proxy pattern, but I'm just curious to hear your thoughts on how the compiler handles storage layout today. And then in particular, in relation to the delegate call proxy, it seems like one of the main pain points is that there's this linear storage layout requirement done by the compiler where you have to lay out your variables in a sequential order. but just, I haven't thought about this deeply, but like what if instead your storage layout was constructed such that you just took the hash of the variable names and you didn't have to deal with a linear layout every single time?
I would relate to the first talk we had about Solidity. We could have better way of storing the variable, and the compiler could also extract the information and print to the user where the variable in memory. And yes, if you use like the hash of the name of the variable as offset, it will be less complex, let's say. You still have the issue because Solidity allows shadowing of variable. So, but yeah, you can use like the name of the contract, dot the name of the variable or something like that. You can come up with a better memory layout, let's say.
Cool.
You primarily focused on Solidity in your work, or is it generalized smart contract frameworks to analyze their security?
You mean for upgradability?
For availability, this talk was Solidity specific, and so I'm saying, do you have more general?
So most of the work I've done about upgradability was to see what are the current solutions. And right now, the current solutions are for Solidity. We could have feature for other language like Viper or any other language to have this upgradability. But as I am not aware of any works to this direction from other language. It's definitely something like if you wanted to have a good upgradability to a smart contract system, it's definitely something that should be done at the language feature. Not sure how to do it, but it's something that should be done at this level and not using hack on the EVM.
How do you feel about like Delegate's call design pattern taking away a lot of the functionality for the tooling to make like good reasoning about security and contracts? Like the tooling can't really do a good reasoning on Delegate call.
Oh, you mean like to follow, for example, you want to analyze a contract, a token, and use this delegate call proxy pattern, and it's really hard to follow the transaction and everything. Yeah, it's another another issue because right now it's a bit difficult to follow internal transaction in A2. So if you want to analyze what's going on with a contract using the delegate call proxy pattern, you need additional tooling to really follow what's going on because they use internal transaction. If that was question.